Hi guys. So today we're going to look at polynomial long division and synthetic division. So before we start, we're just going to review regular old long division like you learned back in elementary school. So if I were to divide this, I would have 5 going into 31,272. 5 doesn't go into 3, but 5 goes into 31 6 times. I would multiply, then I would subtract and bring down the next number. And then I complete that process over and over again until I reach this point. At this point, you have a remainder, and you probably learned a couple different things. You could put a decimal point and a 0, and then bring down the 0 and continue with the decimal. You also could write the remainder as a fraction, and that's what we're going to do today. So we'll go ahead and write that as 6,254 and 2/5. So that same process is what we're going to do for polynomial long division. So let's go ahead and look on this first one. So just again, remembering some vocab, this is the divisor, the dividend, and then the answer is the quotient. So to set this up, I would have x squared plus 3x plus 1 on the outside, 4x cubed plus 2x squared plus 3x plus 5 on the inside. Then what's a little bit different, I don't need to find something that this whole thing goes into all of this. Instead, to come up with a number that goes up here at the top, I'm just going to look at those first terms. Well, x squared times 4x would give me 4x cubed. So once I have that number at the top, I'm going to take that 4x and multiply it by everything that's over there. So 4x times x squared is 4x cubed. 4x times 3x is 12x squared. 4x times 1 is 4x. Then the next step in division is to subtract. And this is where the mistakes tend to happen, so you need to be careful. Since we're subtracting that entire polynomial, what I usually do to keep up with it is I change that minus to a plus, and then I just change the signs of everything that follows. So now this is negative 10x squared minus x, and bring down the 5. And then I do it again. I look at my first term and that first term. Well, that's going to be minus 10. Multiply that negative 10 by everything. So negative 10x squared minus 30x minus 10. And then I'm going to subtract everything. And then I'm going to go ahead and change this to a plus and change all my signs. So 20, I lost. There we go. So 29x plus 15. And at this point, you'll notice that what I have down here is a lower degree than what's over here. And once you reach a lower degree there, everything that's left over is your remainder. Now we are going to write our remainder as a fraction over the divisor. So this would be 29x plus 15 over x squared plus 3x plus 1. All right, let's look at example 2. So very similar setup. X squared plus 2x minus 5 gets divided into 6x to the 4th plus 5x cubed plus 0x squared plus 2x plus 8. Then I look at my first terms. So x squared times 6x squared would give me 6x to the 4th. And then multiply it times everything. So 6x squared times 2x would be 12x cubed, then minus 30x squared, and then I'm going to subtract everything. I realized I didn't really make a note of this. If you notice, I put that 0x squared in there. That's just because I think it's helpful to keep everything lined up with the same term. So if a term is skipped, I'm going to fill in those zeros just to make it a little bit easier to work with. So now at this point, I'm subtracting, so I'm going to go ahead and change it to plus and change my signs. So then this is negative 7x cubed plus 30x squared plus 2x. If you want to go ahead and bring down the plus 8, you can. If you want to wait, you can wait. It's really just up to you. And then we go again. So first terms, that would be negative 7x. Multiply that negative 7x by everything. So that's negative 7x cubed minus 14x squared plus 35x. We're going to subtract it all. So I'm changing that minus to a plus and changing my signs. So now this is going to be 44x squared minus 33x plus 8. Then the last one I'm going to do, again, look at my first term, so plus 44, 44x squared plus 88x minus 220. I'm going to subtract all of that, change it to a plus, change my signs, and I get negative 121x plus 228, which I will write as my remainder. So my answer here would be 6x squared minus 7x plus 44 plus negative 121x plus 228 over the divisor. And that is my polynomial, or my quotient. Now notice, even though there was a negative here, I went ahead and put plus. That's just because if I use a negative in this space, I need to be careful because I'm now subtracting that whole fraction. Then you have to consider that negative was factored out. So I typically am always going to write plus and then just put whatever sign is on there. All right, so if you feel comfortable, pause the video and try example 3 using long division. All right, so x minus 5 is being divided into 2x cubed minus 10x squared plus x minus 5. Again, I look at those first terms. That would be 2x. So 2x squared. That would be 2x cubed minus 10x squared. When I subtract, a little bit different this time, everything cancels out. Well, we'll bring down the x minus 5. I get 1. And again, everything cancels out. My remainder is 0. So if my remainder is 0, that actually tells us a couple things. One, that means that that original dividend actually factors into 2x squared plus 1, x minus 5. So my answer to that quotient is 2x squared plus 1. But because that remainder is 0, that shows me how I can factor that problem. That's going to come back up here in a little bit. Now this one you probably would have known, hey, I can just do grouping in order to be able to factor that out. But some of these we're going to look at later. You'll need a factor, and grouping is not going to work for us. All right, so now, depending on what you're dividing by, there's another process called synthetic division. Synthetic division works best when you're dividing by that first degree binomial, so like x plus or minus some number. If that's what you're dividing by, that's when synthetic division is going to work. So if you divide by x minus a, then a is going to go in a box in the top left. So I'm dividing by x minus 5, so positive 5 goes in a box in the top left. I'm going to list the coefficients of the dividend, which would be 2, negative 10, 1, and negative 5. If there are any skip terms, I have to fill in the 0. So while it was a good idea and kind of helpful for our long division questions, it has to be done in synthetic division or it's going to mess up our answer. The first step is to bring down your first coefficient. So after you brought down that first coefficient, what we're going to do is we're going to multiply by the number that's in the box. So I'm going to take 2 and multiply it by 5 and write it in the next available spot. Then I'm going to add down the column. And then I'm just going to keep doing this process until I get to the end. So 0 times 5 is 0, add down the column. 1 times 5 is 5, add down the column. So the way this works, the last number that you get is the remainder. The other numbers you get are the coefficients of the quotient. Those coefficients start 1 degree less than the original dividend. So the original was x cubed, so this would start at 2x squared. So 2x squared plus 0x plus 1. So my quotient would be the same thing I got with long division. Biggest mistakes typically with synthetic division is putting the wrong sign on this number or forgetting any zeros that may need to go in that spot. All right, so again, let's look at the next one. We're going to put 2 in the box in the top left. I'm going to write my coefficients. So 2, 0x squared, negative 5 and 8. So don't forget that 0. Bring down the first number, multiply by what's in the box, write it in the next spot. Add down the column. 4 times 2 is 8. Negative 5 plus 8 is 3. 3 times 2 is 6. Add down the column. Last number is the remainder. So then I would write 2x squared plus 4x plus 3 and then I would write my remainder as a fraction over the divisor. All right, very similar on the next one, but this time I'm dividing by x plus 1, which means negative 1 is going to go in the top left. So let's list our coefficients. So 2, 0x cubed, negative 4, 2, negative 3. Bring down the first. And then continue that synthetic division process. Multiply, add down those columns. Last number is the remainder. Coefficients start 1 degree less. And then my remainder, again, I write as a fraction over the divisor. And that is my final answer. All right, so now what we're going to look at, there's an extra example that we did on Pear Deck. What we're going to look at now is what happens when it's not just x plus or minus a number. With synthetic division, it's a little bit harder. There's an extra step that tends to be forgotten. So what I typically recommend is if you see some number here in front of the x, I would go ahead and use long division. Now this one in particular is a little ugly because it gets into the fractions, but we'll go ahead and work it out. So 2x goes into x cubed. That would be x cubed basically divided by 2x. That's 1/2 x squared. Multiply that by everything. That's x cubed minus 1/2 x squared. And then I'm going to subtract. So that becomes plus, change the signs. So negative 1/2 x squared minus 3x. Then I do it again. So to figure out what goes here, it's negative 1/2 divided by 2. So that's a negative 1/4 x. Multiply it by everything. And then subtract. I'm going to change my signs. That's negative 3 1/4, which is negative 13 over 4. Bring down the plus 1. Negative 13 over 4 divided by 2 would be negative 13 over 8. Multiply that. This would be plus 13 over 8, and then I would subtract. Change my signs. 1 minus 13 over 8, that's 8 over 8, minus 13 over 8, that's negative 5 over 8 as a remainder. The remainder is a fraction over the divisor, so that 8 is actually going to be on the bottom with the divisor, and that's my quotient. Now the problem is if I try this with synthetic division, if I just try and plug in 1/2, you're going to notice I get pretty close to my answer, but not quite there. So not quite, but I'm really close to those answers. The reason it's not working out the way that you think it would, what goes here is technically what we get as a result of x minus 1/2. Now, I'm not dividing by x minus 1/2. I'm dividing by something that has the same root, but I'm dividing by 2x minus 1. That's not the exact same thing. In fact, 2x minus 1 is the same thing as 2x minus 1/2. As if that 2 were factored out. So in order to actually have x minus 1/2 in the format I would need it, I actually have to rewrite this equation as 1/2 times this function. And because that's how it has to be rewritten, because the only way to do synthetic division is if I'm using something that's x minus a, well then I have to take that result and I have to multiply that result now by 1/2. So it'll be 1/2 x squared minus 1/2 x minus 13 over 4. And then that remainder is actually written as 8x minus 1/2. So let's go ahead and distribute that, and then you'll notice I have the same thing as my original. Now, it may look a little different, especially on the remainder, but if you look at the remainder, if I were to FOIL that out, that's a squared, or 2, sorry. If I were to FOIL out that remainder, I'd have 16x minus 8. Well, this is also 16x minus 8. It's just written a different way. So basically, if you have a number in front of your x there, if it's the leading coefficient is not 1, I would use long division because it's a hard step to remember. So typically just use synthetic division if it's x plus or minus some number. All right, so the last things we're going to look at are just some applications of synthetic division. So like we said, synthetic division really only works when you have a first degree binomial. It says the remainder, when you divide by x minus a, is actually the same as evaluating f of a. This is something called the remainder theorem. And that's going to be really helpful for us when the remainder is a particular value. So the remainder theorem is shown here in example 5. So it says, given that function, evaluate f of negative 2 using synthetic division. Well, by the remainder theorem, f of negative 2 is the same thing as the remainder when I divide by x minus negative 2, x plus 2. Well, if I divide by x plus 2, negative 2 goes in the box, and then I can do synthetic division. And I get negative 23. Well, the remainder then is what f of 2 is equal to. So f of negative 2 in this case is the same thing as negative 23. Now the reason this is helpful for us is if we get a remainder of 0. If we get a remainder of 0, that means that f of that number is equal to 0. That means that that number is a 0, which means that x minus that number is a factor of that polynomial. And that's what's going to be really important for us. So here's just another quick example that we did on the pear deck. So f of negative 2, if I wanted to evaluate that, I could do negative 2 with synthetic division. And the remainder is going to be my answer. So I get a remainder of 1, which means that f of negative 2 is equal to 1. All right, so the last application, this is what we're really going to get into next class. Let's say I have something that I cannot factor or I cannot solve. So this, if I try to factor this by grouping, it's not going to work. It's going to tell me that 3 is a 0. Well, if 3 is a 0, then if I do synthetic division with 3, I should get 0 as a remainder because f of 3 would equal 0, or f of 3 does equal 0 if it's a 0 of that polynomial. So let's go ahead and do our synthetic division. And the bell might ring here in a second. I apologize if it goes off in the video. All right, so I get 0 as a remainder. So since I get 0 as a remainder, that is proof that 3 is a 0. If 3 is a 0 of this polynomial, x minus 3 is a factor of that polynomial. Well, to get the remaining polynomials, what I'm left with now, 1 degree less, I'm left with a quadratic. Well, that quadratic can now factor. And since that quadratic factor is there, you have the other factor to include that we already found, and now I've factored that polynomial. Now, this is what we're going to get into on Friday and Monday. The only difference on Friday and Monday, you're not going to be given that starting point. So we're going to talk about a theorem that helps you find the possible answers that could be there. Then we're going to use synthetic division to test which of these are actually zeros.